Are you able to see that?
Yes.
Yes.
Now, this is the BS 7671, and it's not IEE, or it's not IEEE. It is an IET. You see where the hand is, IET. IET, Institution of Engineering and Technology, Wiring Regulations, 17th edition. This is our Bible as far as wiring is concerned. If you go through these standards, even the definitions, that please mute yourself, please. If you go through this standard, there is a lot that you'll be able to learn, including definitions, and even safety. So I just want to even supplies, environment. We have types of wiring methods and method of installation, accessibility, what is frequency, power, all definitions now here, current impulse, accessory, ambient temperature, all these bonding. When you talk about bypass, when you talk about cable, channel, caravan, circuit. So a circuit, is an assembly of electrical equipment supplied from the same origin and protected against overcurrent by the same protective device. That's what we are going to talk about. There's also circuit breaker and the other classes of equipment, and even conduits, consumer unit, and distribution board. I think that one you'll go through. But for me, I like going through. There's a page, and I want you to take note of this page, 333. Page 333, you can rotate it. You can rotate it right. On this page 33, there is something called copper conductors. Are you able to see that?
Yes, we can see that.
And then there is a table 4D1A, single core, 70 degrees Celsius thermoplastic insulated cables, non-armored, with or without a ship. These are the tables that we're going to refer to. These are the tables, but let me just update this. Including multi-course, so this will be our point of reference, and also I want to share with you another document. Are you able to see that Word document? Proposed civil servants.
Yes.
Yes.
Very good.
Yes.
Now this is a typical load schedule. This typical load schedule give us the loads that we have in an installation. The Kiambu Civil Servants Housing Scheme project, we have we are rebuilding residential blocks for civil servants. We have two blocks, and each block has 1-bedroom units. So for 1-bedroom units, we have 2 blocks. For 2-bedroom units, we have 2 blocks. And then for 3-bedroom units, we have 3 blocks. Now for this one bedroom unit, and I'll call it 1A and 1B. Then for 2-bedroom, I call it 2A and 2B. Then for 3-bedroom, I'll call it 3A, 3B, 3C. Are you together?
Yes.
Now, these bedroom units, each one has 6 floors. 6 floors. And 6 floors, I mean from ground floor to 5th floor. From ground floor to 5th floor. There is a block, one of the 1 bedroom blocks should be 1A, which has a lower ground with daycare. And also there's another one, 1B, I think it has an additional units. I'll take you through that. So, and each floor for different arrangement has a certain number of units, but they are typical. So let's start with the lower ground floor with the daycare. Let's start with daycare. What are the loads in the daycare? Right? Now let me share another one. Are you able to see the new Word document that I have shared?
No.
No.
There is a proposed civil servant housing scheme load schedule, which has the total load down there of 880.7, 808,807. Are you able to see it?
Yes.
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 It is currently it's the one I'm viewing.
So.
This is what I want us to talk about. This load schedule, the lower ground floor with the daycare has fluorescent fittings. The quantities you are able to get the quantities from the drawing that we'll have designed. Then what is the wattage of each fluorescent? And then the calculation. You'll realize that in this case we did 12. Excuse, is there anybody having a question or any clarification? Okay, I continue. So in this case, you will see that we have 1236, and then for calculation, you have done 12 times 36 times 1.8, which is bringing us to 777.6. This 1.8 is a factor. When you are using the what we call fluorescent, zile za kitambo zenye ziko na chalk, lazima uta consider factor 1.8 because there will be some losses in the chalk. Hizo za kitambo zilikuwa na chalk. Hizo za kitambo si kama LED. When we are using LED, we will not multiply by 1.8. When we're using LED, we'll just go straight, and I'll show you a project that I have used LED. Sorry, I thought I wanted to highlight this thing. No color. And then the ceiling rows. Ceiling rows ni ita ya kawaida tu. Hata hapa kwangu pia mimi natumia tu ceiling rows. Ceiling rows ni hiyo ya kawaida, and you just take 7 times 20. For this one we will not multiply by any factor because they don't have the chalks. Actually, just then the bulkhead you will take 7 times 20 times yeah, that's 7 in number, and each one is 20 because the bulkhead is an enclosure and then done in a bulb. For office light, it is what we call 4x18 panel. Nowadays we have an LED, so LED has replaced this. So again, this one will multiply by 4x18, and then it will multiply by 1.8. For ball fitting ile ya bathroom, again hiyo ball fitting ya bathroom inatumia tu bulb ya kawaida. Again it will be 9x20, that 9 in number. Then for a cooker point, in this case we said for 4,500. For a twin socket, there are 24 in number, and each socket is 300. each single socket. I'll take 24 times 300 times 2, then multiply by 0.2. 0.2 is the demand diversity factor in this case. And then the single sockets, I'll take 1 times 300, and then I can multiply by 0.2 for diversity purposes. So the total load for the daycare is 807.2. So for this load, I want somebody to calculate the current because it is single phase. There's no three phase here. I want somebody to calculate the current. What is, if the total load in watts is 1,807, what is a, if that is power in watts, what is the current? And take power factor to be 0.8. Can somebody do that right now? No, who is doing the calculation? Who has done the calculation? Yes.
45.87 amperes.
45.87 amperes.
Yeah. Yes.
Right?
Yes.
Yeah. Thank you so much, Ruth.
Welcome.
Yeah. Now, this is the current for the daycare, because the daycare has its own consumer unit. Now we want to calculate, we want to do what we call, we want to size the circuit breaker and even the cable that will supply this consumer unit. So, and that's where the BS7671 comes in. There is I hope you are writing right now. There is a formula that you normally write when you are sizing, right? ID, I subscript D, less or equals to I subscript B, less or equals to I subscript C. I want you to write that. I subscript D less or equals to I subscript B less or equals to I subscript C. I subscript D is the design current. What you have calculated, like in this case, it is 45.87 amperes. What Ruth has calculated. Then IB is the size of the breaker. The size of the breaker. Then IC is the size of the cable. So in other words, what we are saying is, you start with the size, you start with the design, you get the design current. Then the size of the breaker should be more than your design current. And then the size of your cable should also be more than your breaker size. Why do we do that? We do that because we want to protect our circuit. Remember, think of a situation whereby, and it's a very bad situation, and this is what normally happens. Wewe design current yako ni 45 amperes, lakini ume protect na breaker ya 30 amperes. What will happen? It means your circuit or your installation itakuwa in a trip every now and then, because the maximum that your circuit can, the maximum that your breaker can allow is 20 or 30 amperes. Yet your demand, your current demand is 45. So every time you unajaribu kuweka load zako zote, ikifika 20 in a trip because umeweka breaker ndogo. So unaweka breaker ambayo ina support load zako zote. And in this case, take a breaker ambayo ni more than 45.87 amperes. Then why does the size of the cable supposed to be more than the size of the breaker? It's because when you have overloaded your circuit, the cable must be able to carry that overload current so that the circuit breaker can safely trip. In other words, if you have your cable with a current carrying capacity of 40 amperes and your design current is 45, what that means is ukiweka load zako zote ambazo zimefika 45 yet cable inaweza kabeba 40, so the extra 5 hizo, the extra 5 amperes with the time it hit the cable because there is something called I squared R, that is heat. I squared RT. You must have learned this, whereby I is the current, R is the resistance of the cable, and T is time. With the time, the cable will hit, and that is the kachomeka. Tunaelewana hadi hapo?
Yes. Yes.
Okay. So now, like in this case, tukisema kwamba tunatumia breaker ya 63 amperes. Halafu, the current carrying capacity of your cable that you have chosen is 50 amperes. So it means even 60 amperes can flow through the cable and the breaker will not trip because the breaker is supposed to trip at 63, the MCB. But in this case, remember your cable can carry up to 50. So you are overloading your cable, and with the time, because of I squared RT, which is heat, the cable will be heated, and that is the cause fire. In most cases, up on your electrical faults. So with this 45 amperes of ours, let's go to the table. Are you able to see the table?
Yes.
Now this table, we are going to start with this table, single core, 70 degrees Celsius thermoplastic insulated cable, non-armored. Because ni kitu ya consumer unit, unajua consumer unit lazima ipitie kwa pipe. In this case, tunatumia single core.
Hello, excuse me, I cannot see the table. Which table are you talking about?
The BS7671, the IET edition. Are you able to see?
No, we cannot see that one. We still have the load schedule.
Oh, you still have the load schedule? Okay.
Yes. Yeah, we can see that.
Yeah, now this table, I want us to refer to the single core 70 degrees Celsius thermoplastic insulated cables, non-armored. There's even a table, ukisonga huko chini utaona table ya armored. Sasa hapo utakuja angalie. Reference method A, enclosed in conduit in thermally insulating wall. Reference B, enclosed in conduit on a wall. Remember this one is in a wall, and here now you go in a wall. Method C, direct. Method F, on a cable tray or free air. So for us, we want, because it was in a conduit and a conduit was in a wall, I want to use the reference method A, where my hand is. I hope you are able to see that. And then it is single phase. It is not three phase. In this, it is single phase. Now, since it is single phase, oh, yeah, we now have unlimited. Okay, thank you, John. Now, since it is single phase, we shall use column number 2. I hope you're able to see column number 2.
Yes.
Then column number 1, where my handle is right now, is the cross-sectional area of the conductor that we are going to choose. So our design current, we are going to be guided by our design current. Our design current was 45.87. Definitely, we cannot use 4. Excuse me. Mute your mic. Cannot use 34. We can use 10. Dad, mute your microphone. Thank you. I want to take note of 10 because 10 it is maximum current carrying capacity is 46 amperes. And also I want you to take note of 16 millimeter square. It is maximum current carrying capacity is 61 amperes. Yes.
Okay, echeza ni kiasi gani echeza wako nayo kokoti?
Bernard, mute your mic. Bernard Omolo, mute your mic. Thank you. I want you to note 10. For 10, we'll have 46 amperes. That's maximum. And 16, we'll have 61. 16 will have 61. And our current carrying capacity was 45.87. Was 45.87. So ID 45.87 less or equals to ID, the breaker. The breaker, in the market, we have a breaker of 45 amperes. Or 40, or even 40. But in this case, because our design current is 45, if we have to go for that breaker, then we can only go for 45 and above. Then we will have 46 amperes. That is for 10 millimeter square. Then for 16 millimeter square, we'll have 45.87 less or equals to 45 amperes, less or equals to 61 amperes. Now, the 61, the reason why, according to the breakers, we have 5 amperes MCB in the market. We have 10, we have 20, we have 30. We also have 32. We have 40. We also have 45. 50, I've never seen 50. From 40, we go to 45, and then from 45, we go to 63. Now, in this case, if we go by the first arrangement, 45.87 is less than 45 amperes. So definitely that one cannot work. 45.87 is actually is more than 45 amperes. So, and then our currents, they are so close. You see, imagine we talk about 45.87, unaenda 45, unaenda 46. So I'll advise that at least we look at 16. So 16, for 16 we'll have 45.87, which is less than 45 amperes, and then that cable can carry up to 61 amperes. So that arrangement can work. If you decide to use 16 millimeter square, it will work. It will work. Are we together? Kufikia hapo hivyo, hii table watu wameelewa, nimetoa hizo values. Hii ya 1046 na hii ya 1661. Watu wameelewa?
I have a question.
Then note. Yes, please.
Now, you've said that we don't have a circuit breaker that is between 45 and 63.
Do you have a circuit breaker of 50 amperes?
I don't think so.
I also don't think so. From experience, I've not seen it.
Yeah. So have you settled on 61?
We have
On the
settled on.
16?
I have settled on 16 because 16, it is current carrying capacity is 61, right?
Yeah.
And I have chosen a breaker of 45 amperes. Okay.
Yeah.
And my design is 45.87. This 45.87, I can decide to truncate it so that I assume this 0.87, I truncate it. it's almost equal. That arrangement can work, and you have already protected your circuit. But ideal, if you are supposed to go to the next cable, which is 25, you see the next cable of 25 for 25 millimeter square. Our design current still is 45.87, and in this case we can go to 63 amperes because unajua 45, ukiona 45 ya breaker na hii 45 yako yenye umedesign iko karibu sana, you can go to the next, which is 63. If you go to the next, which is 63, inamaanisha utaenda to the next cable, which is 25, ambayo 25 has current carrying capacity of 8 amperes. If you are using 63 amperes breaker, do not use 16. That's a mistake that we normally do. From the BS standard, if you are using a 63 breaker, 63 ampere breaker, 63 ampere breaker cannot protect 16, a cable of 16, because hii cable itakuwa overloaded, itakuwa maybe inaenda above 61, na hii breaker yetu ya 63 nayo ija trip. So for ideal protection, you'll have to go with the 25, which has 80. In this case, 80 itakuwa inashinda 63, na 63 pia itakuwa inashinda 45. And you will even give room for expansion. Utaongeza loads zingine in future. Have I answered you, Dan?
Yes. Yes.
Yeah. So in this case, for me, I'll settle on a 16, and I'll use a main income breaker of 45. Okay. So I want us to go back to our load schedule. Are you able to see our load schedule, or you are still seeing the PDF?
The load
You can see the load sheet.
Oh, you can see it, eh? Thank you. So that's how you calculate for that. So it means you'll have your consumer unit, and this consumer unit, it will have a breaker, a double pole of 45 amperes. Now you want to circuit, you want to divide the circuits. Circuiting means you just divide the loads. In this case, we have the loads of lightings. Lighting ndio mingi. So none fluorescent, so lighting. Under lighting, unaweza kusema lighting zikuwe circuit mbili for the purpose of balancing. Because easy lighting ni nyingi sana. Imagine you have 12 plus 7 plus 7 plus 1, then plus 9. So you can say you'll have 2 circuits for lighting. And also you can say that you'll have 1 circuit for cooker. A cooker must have its own circuit. Hata tungekuwa na shower ingekuwa na circuit yake. Then for the sockets, they are 20, what, how many are they are 20, like I said, that 25. For this socket, you will need 3 circuits. Why am I saying 3 circuits? Because in our design at Public Works, we have adopted a standard of having a maximum of 10 sockets per circuit. A maximum of 10 sockets per circuit. And that is a twin sockets, 10 twin sockets per circuit. So in this case, if I have 25, so the first 10 zitakuwa circuit moja, second 10 zikuwa circuit ingine, and then the remaining 5 zikuwa circuit ingine. That is a standard that we have adopted because we don't want to overload the cable. Remember, we normally, for sockets, we normally use 2.5. And 2.5, are you able to see the PDF?
Yes, we can see.
Hello? Okay. 2.5, it is maximum carrying capacity is 20. So I want you to calculate, I want you to do the calculations. On 20 amperes, ni wattage ngapi? Hebu mtu anipigie hesabu. 20 amperes ni wattage ngapi? Yeah. Power is equals to VI equals theta. V is 240. I is 20. Yenye tumeona hapa. Cos theta is 0.8. Mtu amepata ngapi?
3840.
38?
40.
3840.
Yeah.
Now this let's go back to our load schedule. Now our load schedule 3840. See, hata hizi that circuit it can carry hizi socket zote hata zikiwa hivi, because for the socket you have 2880 plus 60, which is 2940. But the reason why we normally do 10 twin is because we we feel that with the 10 twin will mean 10 times 600, which is 6,000. And then with a diversity factor, maybe we can say a diversity factor of around 0.5, it will come to around 3,000. So 10 is an ideal number because it will not go beyond 3840. It will not go beyond 20 amperes that a cable can carry. We are sure. So wewe usichukue socket zote alafu unaweka kwa socket moja. Just work with 10, 10, 10, 10, 10, 10, 10, 10. Another rule of the thumb that we normally use at Public Works is that your circuit of a socket, it should be within an area of 100 millimeters square. It should not go beyond 100 millimeters, 100 meters square. I mean, it should not go beyond 100 meters square. Meaning, sometimes we normally have big projects. We normally have big projects zinaenda ziko na distance kubwa. So inamaanisha usiweke circuit yako sorry guys, niko na homa lakini ni sawa. Usiweke circuit yako beyond an area of 100 meters square. So like if you have a square of 10 by 10, so that is the area that can be covered. But ukienda beyond that, hiyo kutakuwa na voltage drops ambazo zitakuwa nyingi sana. Excuse me. Yeah. So I have brought in something called voltage drop. I want us to talk about voltage drop. Umesikia mara nyingi sana watu wakisema kwamba sipati stima enough, ama stima yenye nakufikia haiwezi hata ikawasha taa ama taa inawaka ikiwa dim ama haiwezi fanyisha fridge haiwezi yaka. It's because you have gotten a low voltage. You see, the voltage that you are supposed to get is to 40 volts, but along the way, because our cables are resistive in nature, we normally have voltage drops. Now, those voltage drops, we have the standards. It cannot go beyond a certain level. For single phase, you are only allowed to have voltage drops of 4%. Then for three phase, you are allowed to have voltage drops of, is it 16% or what? Let me just confirm from my archives. Are you able to see the PDF?
Yes.
Yes, we can see.
Are you able to see my design report?
Yes, you can see.
Yes. Now the voltage drop. The voltage drop allowed is 4%. I think that's the calculation I was doing. Yeah, it is 4% for three phase, and then it is 16.6%. Or I'm not sure for single phase. You'll just confirm that. I'll be able to direct you somewhere that you can confirm that. In that BS7671, you can search voltage drops. You can search voltage drop. I'll be able to get you the exact percentages. But for three phase is 4%, and then for single phase it is should be for 14% or 9.6%. I will confirm with you. I want you to calculate the voltage drops for this case. Voltage drop for this case, you need to calculate, but you'll check. You see, unaona hii table.
Yes.
Teremka chini, hii table yenye nafuata, hii table 4D1B. Iko on voltage drop per ampere per meter. So like utaenda kwa cable yetu tumechagua, we have worked on 25 and also 16. So for 16 millimeter square, they allow the voltage drop for two cables, two cables DC, and then you have reference method A and B, two cables single phase. We are going to use column 3. For 16, it is 2.8 millivolts per ampere per meter. I want you to read that. 2.8 millivolts per ampere per meter. And for 25, I'm having here RXZ is mambo yenu sasa, where R is the resistance, X is impedance. Impedance ama ni whatever. Alafu Z ndio impedance. I'm interested in Z impedance 1.8. Hapo mnajua sana kuniliko sasa. 1.8 millivolts per ampere per meter. Now, once you have confirmed that, you just come to unapiga hesabu ukitumia ile design current yako. For 16, utachukua hii 2.8 times 10 raised to negative 3 meters. You convert everything to the standard units. Our current is mingapi? Current yetu. Our design current was 45.87. Then the distance. What is the distance that cable shall run? So in this case, it was around 20 meters or even 10 meters. But let's work with the 20 meters. Hiyo inakuwa ngapi? 2.8 times 10 raised to negative 3 times 45 times 20. Nani ananipigia hesabu? Jacinta wewe ndio unanipigia hesabu. Eh, 2.8.
Tumesema?
Tukua 2.8 multiplied by 45.87 multiplied by 20.
Nakuja 2.5.
2.5.
0.57.
Okay, 2.5 volts. So those are the voltage drop that we are going to have. And in a single phase system, we normally have a voltage drop of 4%. So what is 4% of 240? The maximum allowable voltage drop is 4%. What is 4% of 240? Huh?
9.6.
9.6. Yeah. So that's the case. So unaona, really according to our load, using 16 millimeter square, the voltage drop itakuwa 2.5, but ile maximum allowable is 9.6. So we are within the range. But ingekuwa beyond 9.6, ingebidi uende to the next cable. I don't know if we have any questions so far. Have any question so far? Silence means what? Silence means we proceed, eh?
Yes.
Yeah.
Yes.
Anyway. So I've talked about circuiting. I've also talked about voltage drop, and I've talked about I think load calculations, based on our load schedule. Are you able to see the word right now? The word document.
Yes.
So remember, our circuits. We had said that we are going to have 2 circuits for lighting, 3 circuits for sockets, and 1 circuit for cooker. So what is the total number of circuits? 2 for lighting, 3 for sockets, and 1 for cooker. What is the total number?
6.
6.
So you can decide to use a 6-way consumer unit, or you can use a 7-way consumer unit if it's in the market. 7-way is there. There's some other manufacturers that work on a 7-way, or you can use a 9-way, 8-way, or 9-way. In other words, you cannot use a consumer unit which has less than 6 ways, and which has less than 6 spaces for breakers. Lazima tutumie ile yenye ni 6 and above. I will urge you as a designer, you should recommend for an 8-way or a 9-way. Why do you recommend for an 8-way or a 9-way? For spare purposes. For spare. Unajua hii kitu kwa tunaanza kudesign circuits, lakini time yenye unaanza kufanya implementation, client anakuambia anataka aongeze circuits. Unasikia tu client out of nowhere anakuambia anataka niongeze shower. Hapo hiyo na consumer unit yako tayari imejaa. So afadhali weke ile yenye na spare. Weke kama spare 2 3 hivi. So that's what I'll advise you to. So in this case for daycare, you can go with 6-way, 7-way, 8-way, or 9-way. So for me, I'll go with 9-way. I'll go with 9-way. And then now for the breakers, of course, for lighting we use a 10 amperes breaker. That's by design, according to the British standard. For sockets we use the 30. You can also use 20. Then for cooker we use 40 or 45. So those are the breakers. So you ask, how will you name your circuit? I believe most of you mumeona. Let me just open allow me to open a document. Electrical drawings, electrical drawings, 2020 drawings, electrical, main kitchen electrical, yes. Are you able to see the 2 PDFs that I have shared?
Yes.
Eh?
Yes. Yes.
Unaona drawing yote?
Yeah.
Ni sawa. So this is a kitchen, eh? This is a kitchen that we did. We are doing some renovation. Now I wanted to look at this the way I have named these circuits. We have circuit AR4. I also want to share with you another one. July 20, final lessons, 2020. Nimeshare ingine, mnaiona?
Yes, tunaiona.
Now, let me start with this. Kwa sababu hii niko na consumer unit. Hapa salon or whatever, consumer unit 12. Now this consumer unit 12, hizi mataa nimeziita circuit 12I or circuit 12.1, Roman number 1. Haya, nikikuja hapa consumer unit 13, hizi nimeziita circuit 13I. This is a consumer unit. So if you have consumer unit A, B, or 1, 2, so like in this case it's consumer unit 14. So lighting the consumer unit circuit 14I. If I were to show you the sockets, our model for the same. You can see for 12, consumer unit 12, I have named here circuit 12, 2, Roman 2, Roman 2, Roman 2. And you see this one, there are 1, 2, 3, 4. And it's within, this area is not more than 100 meter square. Hapa ni 13 Roman 2, hapa ni 14 Roman 2. That's how you choose to name. Every engineer has a different way of naming his or her circuits. For this project, mimi nilitumia hii method. Because consumer units zenye nilikuwa nazo zilikuwa 56 consumer units. This project has 56 consumer units. So nikiamua kutumia alphabet order, ningetumia alphabet order, ningeenda A hadi Z. Alafu tena nianze tena kwingine. So I just decided I can use the whole numbers. Alafu for circuits nitatumia Roman numbers. Ukiangalia hapa kwa kitchen kuna distribution board DB1 in kitchen 1. Hii hapa penye niko sahi penye kamkono kako. You see nimename socket hapa ni circuit R1. Hii ni circuit R2 Roman 2. Hii ingine ni circuit Roman 2. Hii ingine ni circuit RYB. Hii ingine ni circuit R1. When we talk about circuit R1, we mean one, we have a DB, and a DB when upon a three phases. Kuna red, yellow, na blue. So sockets wote nimesema zikwe red. So iko circuit red 1. Na hii socket pia iko kwa circuit red 1. Nikikuja kwa kuka circuit R2 red 2, that is a kuka. Then nikikuja kwa single pole nimeka R2, lakini I think kama nilikosea ilikuwa inafaa ikuwe R3. Because a kuka is a kuka not share with an isolator. Kuka itakuwa tu kivyake, isolator pia iko kivyake. Then this is a three phase isolator, nimeiweka RYB. RYB meaning ni three phase, inakuwa na red na yellow na blue. Since ni moja tu niliamua tu niweke RYB. But zingekuwa kadhaa ningeweka RYB1, RYB2, RYB3. Vitu kama hiyo. So that's how we do name the circuits. I was telling you, consumer ziko nyingi sana huku hivi. I think sijui zilikuwa ngapi kwa hii project. Now, the same project with the lighting, hapa nimeka DB-R1. I think in circuiting, hii project niliji confuse. Because hii ingekuwa baby yellow face. This one I confused myself. I had a mistake. I'll go and make the corrections. But this one it was sasa, since kwa socket kuna tayari socket ni R1, lighting ingekuwa yellow one ama blue one, ama hii socket ndio ingekuwa tofauti. So I know I confused myself there. But this kuna kingine hapa hivi tunafanya in this case like I was telling you, there is one here hapa penye kamkono kangu kako. I hope mnaweza mkaona penye hapa sahi kwa bakery. There's somewhere written bakery, and then there's a TP. This one I have called it ARYB number 8. Then ukikuja hapa pia penye mkono wangu imeenda, I hope you're able to move with my hand. In the bakery, I have circuit ARYB number 8. Then hapa penye kuna veg preparation area, we have circuit ARYB number 9. And then where is the distribution board? The distribution board is supposed to be somewhere. I didn't indicate it there, but it's okay. We have ARYB 10. If it's three-phase, lazima zote zikue. But if it's single phase, you can say circuit AY4. That means yellow phase number 4. You see here it's circuit AY2, meaning yellow phase number 2. We have circuit AY3, meaning circuit A identifying the distribution board is DBA. Y3 means yellow 3. Ukikuja hapa unakuja circuit AY5, circuit AY6, circuit AB6, meaning DBA, but blue phase, circuit number 5, blue phase, circuit number 6. So generally circuiting depends on how you want to name. On how you want to name your circuit. There's a different way you can adopt that. So and it needs a lot of practice. So si kitu tu yenye utaanza tu mara moja. It needs a lot of practice ndio uzoee. Are you able to see the word document, load schedule?
Yes.
Now in this load schedule, hiyo imekuwa tu daycare peke yake. One bedroom unit, you will do the same. And this is an assignment yenye nataka kuachia practice. One bedroom unit, we will do the same. Upate the total. Ukipata total, utacalculate current yake. 105.59 divided by 0.8 and then divide by 240. 105.59 divided by 240 divided by 0.8. This one is coming to 54. 54.99, which is around 55. So this one definitely utatumia hii. Definitely utatumia 25. So that equals 54, breaker 63, and then the current carrying capacity is 80. That's what you'll use. Ukiweka 54, 63 na cable yenye inabeba 61, omba tu Mungu kwa hiyo nyumba wasiweke loads mingi. Hata wakiweka loads mingi, cable yako itachomeka. Na unajua cable zikichomeka wakuwa naanza tu kuita mtu alifanya wiring, hata kama makosa ni ya mwenye nyumba. Then there's a common area for the entire block. Common area like staircase, then kuna corridors, alafu kuna security lights. Total load yake ni hii. Now we want to have for block 1A, we want to calculate the total current for block 1A. You have to do the summation of the units of the loads. Block 1A has 36 units. So you'll take 36 times here individual units, which is 105. Then you add ile daycare, which is 88.07, and then you add your common area. So unapata 390, 400 watts, you come to calculate the current, but you apply a diversity factor. Again, not all the loads can be on at the same time. So unapata 339.45 amperes. 339.45 amperes, you will agree with me that it is hiyo ni current kubwa sana. Hata tukienda kwa nini yetu, we cannot use it as single cause, or if you were to use them, and remember it's three phase. If you are to use it and run it in a conduit, you see, umepita because 300 can carry up to 328. Umepita, unless if you are going to have that in a cable tray. If you are going to use the single cause in a cable tray, you can use it because it's at 9.45 amperes. It's at 9. If you are to use this reference method F, and which should be touching, remember it's 3 cable. We use 3 cable flat AC. It's 150. You'll use 150 millimeter square for that case. But in the supply cable for that board, we use Ahmad. Excuse. We use Ahmad because cable itapita underground from the transformer room. Now, since single core, okay, you can use this. You can check on this table a single core Ahmad, or you go to multi-core. Multi-core Ahmad, meaning it has several cores. So if you go to multi-core Ahmad, 339, where is it? And then you want to direct ground, near the ground. Around buildings. So 339, here you will use 300. 300 to come and 2 core. 316 kama ni ngapi? Again, here nini. So we'll just use this single core. We'll use the single cores because we cannot use a 4 core. It's not being supported. We'll just use single cores, but Ahmad, and then for 300, and it's this is in a keyboard tray. We can settle on this, 379, 300 millimeter square. 379, 300 millimeter square, 1 or 2. Kuna B, C, yeah. Around there. So you will do the same for block 1B. You'll do the calculation. They are at 9 units and common area. So you'll take that 9 times load per unit, and then you'll add the common area. In this case, you'll get 359. You come to 2-bedroom unit. You start by calculating for a typical unit, and then for common area. And for this case, we have 24 units. So 24 times the power for single unit, and then you apply diversity factor, you get to 28.6. 28.6, you come to the table. 28.6 method D, 28.6 can be around 185 because 243 na paper. Do we have any questions so far? Because I want us to wind up. It's 9:41.
I have a question.
Yes, Daniel.
Okay, for sockets, you said that one circuit should contain 10 of them.
Yes.
will guide you when it comes to lighting, because I just saw you say, let's say, just say used to, but are there some things that can at least guide you?
For lighting, let me go back to that table. We use 1.5, right?
Yeah.
1.5 from this table, it can carry a maximum of 14.5. So calculate the power for that 14.5. 14.5. Then you multiply by 240, multiply by 0.8. It is 2784. 2784. If we go back to our load schedule, how many lights do we have? We have 12, 7, 7, and okay, 7, 7, and
1 and 9.
9. If you add them, if you add those powers, zitakuja ngapi? You add those powers,
62.
There are 52, but if you add the powers, the powers we have 776, 140, 140, 129, 1367, right? Now,
yes.
1367 watts. That's what we have. But the maximum that it can carry is 27.84 watts. The reason why I have decided, why I recommend in this case that we split them to 2 circuits is, kitu ya kwanza, in case one circuit goes over to square in total darkness. That is the first thing. Kitu ya pili, these wattages is what you as an engineer have designed for. Ukishatoka hapo wenda away, the client mwenyewe, the user, ata come up na different wattages. Anaweza kamua, mimi nataka kuweka bulb za 100 watts. Utamfanyaje na ndio mwenye nini? So if we have calculated with the 20 watts and we are getting 2784, suppose hizo ceiling rows mtu akuje na atumia 100 watts, so zitakuwa 7 times 100. Hata kwa bulkhead pia atumia hiyo, so itakuwa 14 times 100, which is 1400. Uongeze kwa ile 1367. Haya, if fluorescent amwe pia atumia ile ya kama kuna ya 54 kwa market. Kwa ball fitting hapa chini pia hizi zenye ziko 9 amwa atumia bulb ya 100, so 9 times 100, which is 900. So kiadi hiyo utapata kwamba will overload our cables, which has a maximum current, a maximum load of 2784. So in this case, I will advise that split the circuits into 2, so that circuit moja ikiwa na shida isikuwe kwamba the client akukwa darkness, and then in case client anaamua kuleta bulbs zenye ziko juu, because yana kwamba the bill si shida kwake, monthly electricity bills is not a problem to him or her. Yana anaweza kama lete light fitting yenye ni kubwa sana. So try to do something, try to leave room for balancing, and in case of any eventuality, remember, we do design for the worst scenario, but of course with reasonable assumptions.
Okay.
Well done.
Yes. Again,
Yes, sir.
in the Githurai design, I saw that it's like each room was having its own consumer unit.
Yes, maybe I can just give you a brief about Githurai, and akina Marvelin and Brian, they know how that project came up, because they are the ones who did this design. And nyinyi ndio mlichora hizi vitu, si mimi. Hii ni yenu. Unaona vile mnajua kuchora.
And why fluorescent?
Now I'm giving a brief. Githurai, we are building market stalls, and it has a is a 6-story. It's a 6-story building. We have ground floor, first floor, second floor, third floor, up to 5th floor. On the first floor, ground first up to 4th floor, we have stalls. Let me just show you where the stalls are. Githurai market. Like are you able to see that? Eh?
Yes.
Guys, now you
Yes,
see like
can
this one.
see.
Is a typical first, second, third, and 4th floors. Stalls to make one stalls to stall. Aya, hii ni same, but unaona sasa ni stalls tu wameweka. Unaona ni stalls that wamename 29, 28, 27 hizo. So in this case, like upper, kuna 26 stalls. First, typical first up to 4th floor, we have 206 stalls. Now, from the brief that we got, remember, hawa wananchi, hawa watu wa kawaida. Na hawa watu kitu ya kwanza, wenyewe watakuwa wanajilipia bili ya stima. Si ati ni serikali inawalipia bili ya stima. So, mwananchi wa kawaida, kitu ya kwanza, unafaa umpe kama light fitting, unafaa umpe ile light fitting yenye anaweza kai-replace haraka na iko efficient. Na kuna choice ya kuchange the consumption. The reason why I gave the fluorescent because iko na hizo qualities. Fluorescent is readily available. Ukienda mahali kwa duka yote utapata fluorescent. Hata ukienda supermarket. The bulbs mtu anaweza kachagua. Anaweza kama nunue LED ya 10 amperes, ya 10 watts ama 20 watts ama 36 watts. Mwenyewe ataamua. And then ikiharibika anaweza kai replace. Na ni cheap. Unlike ningemwambia sasa nikuwekea downlighter, alafu downlighter ikiharibika, what happens? So that's why I decided I use that fluorescent. And then nikiamua yo mtu nimwekee maybe ceiling rose kama hiyo yenye mko nayo kwa nyumba. You see, ceiling rose na kwa ni market, so inamaanisha watu watapanga vitu mingi na vitu mingi zitakuwa zina shift. So mtu anaweza kaamua gonge hiyo kitu. Kwa sababu ceiling rose ni kitu ina hang. So mtu anaweza kaamua na igonga alafu inaharibika. So that's why I decided I'm going to use the fluorescent. That is the most ideal for that situation. That's the most ideal. And you see, if you see fluorescent stall ni fluorescent. Nikikuja hapa ulikuwa unaona hapa huyu mtu wa saloon atakuwa na consumer unit yake na atakuwa na mita yake. Hii mita atajilipia mwenyewe. So sitaki kumwekea zile mataa ambazo zitakuwa expensive sana. Na mwekea mataa ambazo ziko energy efficient ambazo ni fluorescent. Hata pia akikuja bulb the tube ikiungua anaenda ananunua nyingine LED kwa supermarket ama tu hapo chini. Ama hata hapo Githurai kuna mtu atakuwa anauza vitu za stima. Ananunua tu hapo readily. Si ati aende tena Sumbukane, aende alete fundi na ananunua tu mwenyewe anaweka. Same to farmers. That's what made me to choose that. But ukiona hapa kwa stairs hizi S a different form of lighting. It's a standard circular polycarbonate body IP54. Kwa sababu kwa corridor tutakuwa na unyevunyevu. Kwa corridor hapa kwa stairs watu watakuwa naosha, mvua ikinyesha kwa madirisha inapitia inakuja hapo. That's why I decided hapa kwa ramp na kwa stairs. I decided na kwa chopia. These are wet areas, we call them wet areas. So you must have things that are splash proof. And IP54 is a splash proof fitting. Yes, Daniel, have I tried to answer you?
Yes.
So it's all about efficiency and cost and reliability, then maintenance, ease of maintenance. Sawa sawa?
Yes.
Any other question? Silence means?
So I have a question.
Yes, Victor.
So uko na sample drawing ya a distribution board ile yenye ina supply ya consumer units.
Schematics.
Ya schematic ya DB.
Schematic niko nazo. Hizo hatuwezi kosa. Let me just share with you. Okay, Rai and Libot. I have schematics. I think I'll just settle down. Alafu maybe I can get them all. Ulikuwa unasemaje Jonte?
So nilikuwa nauliza the wiring sasa ya from the distribution board to the consumer units. How do you do the circuiting ya distribution board to the consumer units? Una specify aje? Like unasema a certain cable iende kwa a certain consumer unit.
Nimekuelewa.
Yeah.
I'll now have to look for that. Schematic. Where is my schematic? Schematics. Kidogo tu nitafute. Are you able to see the document? PDF?
Yes, we can see.
Now, these are sample schematic. These are sample of a schematic. Like this one is meter body A located on a ground floor. Meter body A located on the ground floor. Nisema from Kenya Power, nikasema hiyo cable, the breaker, nikaeka hizo the bus bar, nikazipeana the rating yake, kapitia cable yake kwa breaker, kwa meter, kwa breaker, then kwa consumer unit. Hapa chini nimeweka the size of those cables. But if you go like this one is a typical 4-way consumer unit SPN. Lazima weke breaker yenye inakuja, then kama isolate yenye inapitia na vile circuit zinaenda. So the first circuit naona na name circuit N means ni is it 1 2 3 whatever. Roman 1 it is 3 times 1.5 single square single core PVCI. PVCI stands for polyvinyl chloride insulated plastic. CU stands for copper cables drawn in HGPVC conduits for lighting. Then hii ingine circuit N. Again, this N it can be 1 consumer unit 1, 2, 3, 4, whatever. And then 2.5 for sockets. These are typical consumer units. These are typical one. Yeah. If I come to 6-way consumer unit in the kitchen, again, circuit N, ya kwanza unaona ni 10 lighting, ya pili unaona ni 30 na ni sockets, hii ingine ni 30 na ni cooker, alafu ingine 40 ni isolator. Maybe kulikuwa na mchanganyiko hapo. So that's how you name them. That's how you name them. Hata una hadi like this is a typical way. This is a typical 15-way consumer unit vile itakuwa. Iko na circuit mingi sana. Hizi ni za mataa kwa corridor. Hii ni typical 9-way consumer unit vile iko na mataa na circuit mingi sana. Kuna extract fan, kuna hand dryer sockets. That's how you name it. I think from the drawings that you have had with your supervisors, you must have come across such like and then it must be act for protection purposes. Jonte, have I answered you?
Yeah, I wanted. Niko nataka hiyo.
Oh, any other question?
Personally, sina ingine.
Okay. I think kuna mtu alikuwa ameuliza about mata yenye tunaweza kutumia kwa nyumba. Are you able to see the screen that I have shared?
Yes.
Yes, you can see.
Laptop. Dogo tu ni connect kwa charger. Now, these are some of the light fittings that you can use in a residential. Lakini hizi ni zile decorative. Hizi ni zile high end. Naona hata vile ziko. So kuna client mwenye anaweza katosha mboga anunue hii. Itakuwa sawa sana. Utakulia kwa meza. Hizi ni pendants. We can also have chandeliers. You see, these are the chandeliers. Mnaona? Hello? Watu wanaona?
Yes, you can see.
Yeah, these are the chandeliers. I'm just trying to make a follow-up on a question that somebody asked about residential lighting. Then for kitchen, again, kitchen you can use this. In an essence, achana na hiyo yenye kwa nyumba yako. I know sasa mko kwa nyumba, hata pia mimi hapa hivi natumia tu hizi ceiling rose bulb ya kawaida. But kama unajenga nyumba yako wewe mwenyewe, lazima uweke at least vitu tamu ndio mtu akikuja kutembelea anapata one or like kwa apartments. Unapata ideas huko hivi. Ni sawa?
Yeah.
I just wanted to make that clarification today so that musinini. Do you have any other question? So I wish to end there, but next week, Jonte.
Yes.
Jonte.
Yes.
Si next week utaniambia nini unataka tushare, si ndio? Unataka tuongelee.
Yes, nitakwambia in the course of the week.
Yes, utaniambia in the course of the week, alafu
Yeah.
Still let me stop sharing. Kuna watu nyumbani. Niko kwa nyumba. Again, I want to insist on this. You need to get in touch with your supervisors so that you can have some discussions on the projects that we are involved in. Because for me, I'm just giving a general discussion, a general overview. But unless you have a project that you are facing the real-time challenges, that concept haitafika. So next week, we'll discuss. We can talk about fire alarm. You can also talk about lightning protection. Then we can also talk about things to do with maybe power factor correction. And we can share, we can have an overview of maybe 1 or 2 projects that I'm handling. So there's a lot that we can discuss, but just make sure that you get in touch with your supervisors.